All right, today we're going to take a look at section 7.4. This section is titled percents. A little bit of vocabulary to start with. The word percent comes from the Latin meaning of per hundred, as in our cent, which is worth 1/100th of a dollar. That is, n percent is n over 100. There are three different ways that we can work with changing numbers into percents. So we're going to take a look at all three of them. Often, depending on the number given, one way seems more reasonable than another way. So these are not like equal opportunity. They all work great for everything. They just don't. But there are cases where they work well in one way and not so well in another. So our first method is to write the number as a fraction with a denominator 100. So in other words, you can take the number 7.9 and you want to put its equal value over 100. So you can also think of this as being 7.9 over 1. If you multiply the top by 100, the bottom by 100. We've written it per 100, as in over 100. And that number on top is our percent. So it's 790%. I know that looks like a funny percent. That's okay. That's not the point, okay? 790% is okay. The second option is as a proportion. Proportions tend to work really well for fractions. Like if you're take it to a fraction into a percent. They seem a little silly for the number 7.9. I get it. But technically they work, so that's why I kept it in here this way. So you write it as 7.9 over 1. You write it as n over 100, and then you'd cross multiply just like we've done in previous sections. So you would get 7,900 equals, I didn't write that right, 790, sorry, equals n when we cross multiply. All right, 7.9 times 100 is 790, 1 times n is n. So this would be 790%. The last one is the one people tend to gravitate toward, especially when the number's not in fraction form, and it's simply moving a decimal point. So if the number already has the decimal, you physically take where it is and shift it. If the number does not have a decimal, you put it in at the end and then you shift it. So we're moving the numbers 7.9, you can put as many zeros as you want, and you're moving the decimal 2 to the right. So here's where it would stop, and you'd end up with 790%. Now, you guys do this all the time with your grades. In fact, when we talked about the redos and I had you calculate what can I still make on my test to get a ABC, whatever it was you were looking for in this, on this test, I told you you're going to take this number, you're going to divide it by this, and then I said, and you're going to multiply by 100. Right? We multiplied by 100 to turn it into a percent. That's what we're doing when we're moving the decimal point 2 to the right. We're multiplying by 100. Okay, so that's the equivalent of that. So we're going to take some numbers and we're going to turn them into percent form. And we can do them in whichever way we wish. So the first one works really well to do as we did on method 3, just shift the decimal. So if I just shift the decimal is currently right here. I move it 1 over, gives me this location, but I need additional 1 because I'm supposed to move it twice. So this ends up giving me 4,260%. Okay, you can have large percentages. I know that's not the kinds of percentages we tend to talk about, but they're not wrong. Now, on B, moving a decimal doesn't really make a lot of sense. Not only is there no decimal, but I don't even have a number in a decimal-ish form. It's a fraction. Fractions work really well to set up as method 2, like a proportion. So you set them up as n over 100 and then cross multiply. So if we cross multiply, I'll have 3n equals 800. And then what would I do? I would divide by 3. Grab your calculator if you'd like. What is 800 divided by 3? $266.6 repeating percent. If you were looking in the back of the book, what they might do, just so you know, is that they might write this as 266 2/3%. I'm not telling you that you should or shouldn't do that, but you just might know that that's something another. This is an equal version of this because 0.6 repeating is the same thing as 2/3. So you might see that in the back of the book kind of answer. Okay, so now we're going, this is moving a number into a percent. So now we're going to reverse the process. We're going to take a percent and turn it into a number. There's two basic ways to do this. One is to divide rather. One is to divide the number by 100. So you might physically do a division. And then the second one is to move the decimal again, but instead of moving it to the right and making the number bigger, we move it to the left and make the number smaller. Okay, so we're going to do a couple. This is 4 1/2%. So as we're taking a look at this doesn't look super friendly because you got a fraction in the middle of it. Feel free to change that into a decimal. This is the same as 4.5%, right? 1/2 is the same as 0.5, so you can write it like that. If it's written like that, that's kind of nice. You can actually move the decimal because you can see where the decimal is. So I can take the decimal then, and I'm supposed to move it 2 to the left. Well, right now I've run out of space. So I need to put the number here, the decimal here. And then I need another number in front of it to move it before. So I'll put a 0 and I'll move the decimal again. So this is now a decimal point with a 0, 4, 5. If you want to put a leading 0 in front of the decimal point, feel free to do so. It's not right, it's not wrong, it's just another version. So either with or without the 0 in front, you get this as the decimal that corresponds to that percentage. B doesn't have a decimal, so feel free to plot it in there if you want. The decimal's just at the end after the 5. Okay, that's fine. You can also think of this like method number 2 was, or method number 1 was, where it says we can divide by 100. So this is 125 divided by 100. And if you grab your calculator, divide that by 100 or do it out by hand, either way, you get 1.25, which should seem reasonable because it's the same thing would happen if you shifted the decimal 2 places. So number 125% becomes 1.25. All right, there's 3 different types of application forms that a percent application can take. So these are the 3 types. One is finding a percent of a number. The second one is finding a percent that one number is of another number. And the third one is finding a number when the percent of that number is known. Okay, so let me just write out a description of how the question would generally be asked in each one of those categories. They won't have a lot of context to them, but it'll give you some sort of the sentence structure of how that looks. So if you're doing the first one, finding a percent of a number, it would say something like this. What is 15% of 32? Okay, what's the percentage of another number? The second one, a percent one number is of another number would look something like this. What percent, we wouldn't usually see it written in symbols, but I'm going to shorthand it. What percent of 47 is 12? Right, we do that with like a class. Like if I wanted to know what percent of the class is boys or is girls or got A's or got B's, right? This is the kind of thing we would be looking for. And the second, or the last one, number 3, is something like this, where it says 13 is 45% of what number? All right. So if you spent 45% of your income, $13 of your income, and it was 45% of your income, if these two things are equal, you could figure out how much your income was, right? That's the idea in that one. Or if you knew that 13 out of your class got A's, and that's 45% of your class, you could figure out how many people were in the class. All right, so what we're going to do is we're going to look at 3 different examples, and in those 3 examples, we're going to identify which of these categories it is as we do it, and we're also going to see how we solve one of those kind of problems. And there's more than one way to do this. The way that your book shows as its predominant option, and that's the one that I'm going to sort of focus in on, is so that it goes back to what we did in section 7 or 6.4. So 6.4 and 7.4 are very similar. Do you remember what 6.4's title was or what it was about by any chance? Aaliyah's looking at for us. What do you find, Aaliyah?
Proportional reasoning.
Proportional reasoning. You can set these up very nicely in proportions. And proportional reasoning is that's good, is usually the way that students first encounter these. So the younger the kids are, they're encountering this from a proportional reasoning standpoint. The older they get, they encounter them from a truly equation standpoint without proportions. And that's why I'm going to show it from that perspective, okay? So when we look at this first question, it says, what is the sale price of a softball if the regular price is $6.80 and there's a 25% discount? Okay, so the nice thing about proportional reasoning for these, especially for percent ones, is that one side of the equation is always over 100. So you automatically can fill in one of the four slots. It's always 100. I don't care whether you put it on the left or the right, you put it wherever you want. The other piece that will happen 2/3 of the time is that they give you the percentage, which they do here, right? They give us the 25. Now, I'm going to take the 25 for what it is, and I'm going to put it in. We're going to talk about another option for how we could set this one up in a little bit, but we're just going to put in the 25 for now, okay? Because it's there in the problem, and it seems reasonable to do that. Now, it tells us, or it asks us for the sale price, but it tells us the regular price is $6.80. We have to figure out where we put $6.80, all right? Is $6.80 is $6.80 the 100% price, or is $6.80 the price of the sale, which is on top? Does it have to do with sale price? Callie? It's the 100% part, right? It's the original amount. What was 100% of the original cost? This is where $6.80 goes. Okay, does that make sense, everyone? Now, there's a caveat to this. I don't know what this value is on top, but it isn't going to answer my question directly. We're going to find this answer, but we're going to have to talk about what the answer is to the actual question afterwards. So to start with, we're going to solve this, okay? So we're going to have 100x equals, what's 6.80 times 25?
70.
What was it? 170. And we're going to divide by 100. And what's that going to give us? 1.7, and since it's money, I'm going to call it 1.70. Now, this is a dollar amount. But it's not the dollar amount of my new price for my softball. What is this dollar amount telling me? It's how much what? How much we subtract off of it. It's the discount I'm getting, right? Okay, and a lot of times in the cash register receipt, it'll actually show it that way. It'll say then minus 170, and then it'll calculate it for you, like on a receipt. You'll see that like that. So what we would have to do then is we would actually have to take my 680, subtract the 170, and we'd get 510 to find the softball price. Now, this is perfectly fine. There's nothing wrong with how we did this, but there is another way to do this too, where the answer at the end is just the answer instead of having to subtract something. What we chose to do is we chose to put the 25% in at face value, correct? But 25% is not how much we're going to pay, it's how much we're going to save. How much percentage-wise am I going to pay for this softball? 75%. If the discount is 25%, I'm going to pay 75%, right? So we could have, alternate form, set this up so that instead of having $25 on top, we could have put $75 on top. Why? Because 75% is what we're paying as opposed to what we're saving. And if we cross multiply from here, and divide, we will very directly end up getting the 510. There's nothing wrong with either method. You do need to be careful, though, along the way somewhere that you recognize or that you at least account for the fact that the question and the number you're getting somewhere along the way are not matching up. The answer's not 170. The answer's not 170. Okay, take a look back at the three different forms. They're on the same page above. Which type of problem is this? Is it percent of a number? Is it percent one number is of another number? Or is it finding the number when the percent of a number is known? Which one is it? It's the first one. You're right. It is. This is problem number one, or type number one. This is finding a percent of a number. What is 25% of a $6.80 softball, right? That's what we found. Next one is ski resort or ski area reports. 80% of its runs are open. If there are 60 runs open, how many runs are at the ski resort? So if we're setting it up in proportion forms, very nice, because I guaranteed get, and I'll put my 100 on the left this time because it doesn't matter, this setup. What else do you know? We don't put the 80 above the 100. Oh, we do. Sorry. I was thinking about the 60. Sorry, in my mind I had the percent and the number of ski runs opposite in my head. Sorry, Cabriana. You're right. It is an 80. The percents go together, right? So 80% goes above the 100%. Where's the 60 going to go? Because it's got to go somewhere. Okay, why is it going to go on the top? It's not 100% of the runs, right? It's the 80% of the runs. So it's going on the same, level of the fraction, if you will, that the 80% went on. And then I'm going to find this one down here at the bottom. So we have this time 80x equals 6,000 divided by 80. What is 6,000 divided by 80? Mm-hmm. 75. 75 what? Runs. It's the number of ski runs. 75 runs. Okay, looking back at the options, what type of problem was this? It is the third one. Very good. We're finding a number when the percent of the number is known. The 80% was what we knew of that number. We found the number 75. All right, next one. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? Okay, this is the hardest one we're looking at for a couple of reasons, partly because the numbers are big, right? The numbers are just bigger than when the numbers were in the other two, so that makes it a little bit tricky. It's also got context that sounds a little bit confusing because it's like uber real world stuff, right? Like people really talk about this stuff in your everyday life, or at least you'll hear it as you get older, talking about the values of houses going up and down, and the numbers are large, and it just makes it feel like it's a little bit more complicated than it really is. Okay, it's a percent problem. So we can set this up just like before. One of the numbers has a 100% on bottom. Like that part's all the same. What is it we're looking for in this problem, though? We're looking for the percent. So the unknown value is the value that's on top of the x this time. I was not given a percentage. This is another one where we can set it up in one of a couple of ways. So I'm going to let you guys decide to set it up, and how we're going to set it up will depend on how our answer fleshes out. It'll be the same answer, but maybe in a different way. So we have two numbers. We have 195,000, we have 159,000. We need to make sure they get there in the right places. The denominator is not always the biggest value. You cannot always think big numbers go on bottom. It's not the way it works. Right? The 100% value, which would be the original value, goes on bottom. Jamora?
Wouldn't the 159,000 be over the 100 because that's how much he originally bought it for?
It will be across from it. So we're sticking with the fact that the side of the equation that has 100 is a side that will only have percentages on it. So the x over the 100 right over there is representing the percentage over the 100%. Okay, so one side is 100%. But the 159,000 will be on the same level from left to right. Mm-hmm. So we will have 159,000 right here. Like that. Okay?
Yeah, so is this one of those proportions that we would get the same answer if it was mixed up?
You can do it in a different way to set it up differently. Yes, you can. So is there a way to put 159,000 over 100? Yes, there is. I think that it doesn't lend itself well to looking at things across the span of all of our questions. So I stick with one side being the percentage side and the other side being whatever else we're comparing. Yes. So the $159,000 is the original price. It's the 100% price, like Jamora said, of our house. The increased price, like our new price going on top, is one option. Was it $195,000? Yes. Now, if you want to do this, you can make your numbers smaller right away, and you can ignore the thousands at the end. It's just a bunch of zeros. You can't do that with any other numbers. Don't go canceling 3 nines at the end on the top and bottom out. Don't do that. I've had students do it before. It only works with zeros, right? But you can ignore the 3 zeros on the end that match on the top and bottom, and that'd be okay. Now, let's actually cross multiply and see what happens. So if I cross multiply this, I'm going to have 159x equals 195, and then I've talked 2 zeros, so 19,500. And then I need 159 over here. And what do I get when I divide 19,500 by 159? Anybody have a calculator?
Where did the rest of our zeros go?
Okay. So if you want to keep the zeros, feel free to keep the zeros, but all I did was divide the top and the bottom by 1,000. So I marked them out.
But you don't have to do that on both sides, though.
No, you can't. You have to do it in all 4 places. Okay, clearly this didn't work. Let's put our zeros back in. Y'all want to see lots of zeros? We'll see lots of zeros. I just reduced a fraction. That's all I had done was reduce a fraction. But if we don't like the fraction reduced, we can leave them all there. We'll just have lots of zeros. So now instead of having 19,500, you've got 100,950,000. You guys get lots of zeros now. Okay, what's 1,950,000 divided by 159,000?
122.64.
It says to the nearest percent, so we're going to do 123. Is that okay? You said 122.6 something?
Yes.
Okay, so 123%. Okay, we need to pause though and see if 123% is really the answer to the question. The question asked, what is the percent of increase? Did the house increase 123%? No, it didn't. If you increase something 100%, it means you doubled it. Right, if you have $5 in your pocket and you increase it 100%, you now have $10 in your pocket. You doubled it. The house price didn't double. Okay? So any idea what the 123% is actually going to need to do in order to give us the percent increase? Take away 100%, the cost of the house originally. The original cost of the house was 100%. The new cost of the house is 123%. So what's the cost of the increase or the amount of increase? 23%. So the amount of increase is 23%. Just like with my softball question, let me make one comment about another way to think about this if you don't like the idea that at the end you don't just have the answer and get to move forward, okay? Because some of the time, this is very bothersome. You think you've done all the work, this is the answer, we're done. And you get at the end and you forget to go back and think about what was the original question. Another way to set this up, one we didn't do, has our 159,000 on bottom. But on top, it's actually talking about how much the price of the house increased, right? Our house price increased. How much? How could you find it? Yeah, you could subtract. We could find the house increase, how much it increased in price by taking 195,000 and subtracting 159,000. This right here could go right here on top. And that number is 36,000. And if I use 36,000 on top and I cross multiply and so forth, the answer at the end will be 23%. And I'll have the answer directly at the end instead of having to do the extra layer of saying, wait a minute, it's not really supposed to be 123. It's 123 minus the 100% I already had. It's 23%. I do something at the beginning to take care of the fact that I'm subtracting something off. Either way, what type of problem is this? 1, 2, or 3? It's 2. How do you know? It's asking for a percent. Number 2 is the only one that asks us for a percent. So it's asking for a percent. Okay, what's left in this section to take a look at is mental math, I think maybe estimation. Oh, and we have interest. Okay, let's do the mental math. Mental math. So we're going to solve the following using mental math. So here's the thing about mental math. I can't see what's going on in your brain. I know it's a shock to all of you. You thought I could, but I can't. So even though it says mental math, you need to write down what you're thinking about what you're doing so that I can see it. But you need to legitimately write down something that your brain can do without the calculator and writing it down. Does that make sense? For example, this says 15% of $42. Okay? We're going to show you how we think about this, but how you don't think about this is, I'm going to take $42 and I'm going to multiply it by 0.15. You could do that in your calculator. It would work. I'm going to take 15% of 42 by setting up a proportion. You can do that, but your brain's not going to do that for you. Right? You'd have to actually do some written down work or use a calculator. Agreed? So you have to make sure that what you're writing down is really what's happening only inside your head as you're doing it. Now, with 15%, it's very nice to break 15% up into 2 values that are easier to work with. How could 15% break apart into 2 easier to work with values? 10 and 5. 10% in particular is very nice to find values of. What is 10% of $42? 4.2. 10% is really nice. It's just a shift of a decimal. You just move the decimal 1 to the left. That's 4.2. Then, if you know that 10% is 4.2, how could you find 5%? Yeah, you could take the half of 4.2. What's half of 4.2? It's 2.1. And then what would you do to find the total 15%? You would add them together. This would give us 630. I think that it's reasonable to say that you could do those 3 things in your head. You could move a decimal to get 4.2. You could take 4.2 and you could divide by 2. And you could add 4.2 and 2.1 together. You could do that in your head. Here's the kicker that you need to know. Mental math needs to be 3 steps or less. If you're ever telling me you're doing something with mental math that's more than 3 steps, I'm going to push back a little bit and say, I don't think so. Our brains don't hold that much at one time. And while you may be able to do it in 3 steps, your 10-year-old that you're working with, your 12-year-old that you're working with wouldn't. So you have to also keep in mind there's a limit to what we can sort of hold in our head at the same time. 3 steps is about it. Okay? Let's take a look at 20%. How could you do 20%? Yeah, you could do 10% and 10%, right? Okay, so we're going to do 20% of 280. What is 10% of 280? 28. And we could repeat that, right? 10% of 280 is 28. Another 10% of 280 is 28. And then what do we get? Oh, that wasn't what I meant to do. Then what would we do? Add them together. This would be one option. And what would we get? 56. Okay. Did anybody think of a different way than to add them together? You could double it. Yeah. So you could take the 28 and then just double it. 28 times 2 at the end instead of 28 plus 28. That would be another way to do that one. 5%. Probably already know what we're going to do for 5%. What are we going to do? Nope, we're not going to do 3 and 2.
Multiply by 2. Multiply by 2 to get 10.
Okay, I'm going to go the other direction, Aaliyah. How about we find 10%? What if we find 10%? What would we then need to do? Divide by 2. So we're going to find 10% and divide by 2 instead of the other one you were suggesting to go that direction. So what is 10% of 320? What is 10% of 32? 320. I already said it. And then what would I do? I would half it. So what's 320 divided by 2? Do you know? There's going to be a 0.6. What did you say? Did you say 1? I didn't hear your 1. Yes. It's $1.60. Okay. What's half of $3? $1.50. What's half of the 20 cents? Another 10 cents. So it's 320. 320 would be half is 160. Okay, 25%. It's very tempting to say, okay, let's find 10% and find another 10% and find a 5% and add them together. But what cardinal sin are you committing if you do that? There's more than 3 steps. There's a much easier way to do the problem anyway. Do you know what fraction 25% is? It's fraction 1/4. If you want 25% of 84, you just want 1/4 of 84. How do you get 1/4 of 84? You divide by 4. 84 over 4 is what? Thank you. It's 21. These are all dollars, so it's $21. Okay, so here's what will happen. We will move on into the last page and a half, 2 pages and a half, whatever's left next time. They'll move pretty quickly. We'll take care of that next time, and we will talk about the test as well. There's a test review set up. You should have received a posted announcement inside of Canvas about that test review. We'll talk about the test next time. We have a test on Friday.